ska bjuda upp Hamid igen. Och vi ska också få besök av Lina Kinning från Green Power Sweden. Ska vi se här. Och Lina, Lina Kinning som inte har hunnit introduceras igen, du får jättegärna berätta vem du är och vad du gör.
Hej på er allihopa, Lina som sagt, en till Lina på Green Power Sweden. Och Green Power Sweden är alltså branschföreningen för storskalig sol, vind och lagring. Jag säger det därför att vi är kanske inte så kända ännu. Vi bildades i maj i år genom en ihopslagning av svensk vindenergi och nätverket för solparker. Och har alltså storskalig sol, vind och lagring bland våra medlemsföretag. Och jag jobbar som vice vd, har ansvarat för havsbaserad vindkraft här på föreningen väldigt länge och energisystemfrågor i stort.
Ja, kul. And we will speak English again. So brace yourselves. But I wanted to start with a question. You will all get to answer all of my questions, so no worries here. But looking at the future development of Swedish electricity production, which changes or trends even do you see as the most significant going forward? Does anyone want to start?
Well, I can continue to speak and then you can correct me later if I'm saying the wrong thing. No, but the trend that we see amongst our members is that they tend to build combination of technologies going forward. So combination of solar, wind and batteries, for example, or even hydro, solar and batteries in the same behind the same meter. And I think that is an answer to the question of the volatility for the grid to handle these variations that Hamid talked about. And I think that is a trend that we will see more of also because of the market changes, how you price imbalances, for example. And so that's something that we see coming very big in Sweden.
Do you share this view on hybrid park extension, Lina R and Hamid?
Right. I mean, that was actually one of my questions to you, Lina, for a later question. But anyway, that's really interesting, and I'd like to know more about that. But okay, so two kind of maybe worrying trends from my perspective is that, I mean, we've seen these forecasts of the future demand where some think it's going to stay more or less the same. Some think it's going to triple in Sweden due to these green steel projects and so on. And some think it's going to double. So basically, we don't know what the future demand of electricity will be. And yet, there seems to be increased vetoes from municipalities regarding onshore wind. So onshore wind development may be stalling, and maybe also because of the government announced those subsidies to nuclear. So subsidies to nuclear means lower electricity prices in the future, which means that the appetite to invest in other production facilities such as wind and solar is less, right? And yet that nuclear, when does it come online, or does it even come online? Who wants to build it? I mean, just the other day, there was this consortium of Vattenfall and some industries that say they are going to build some new nuclear, but who knows? I mean, their best estimate, their most optimistic estimate is in more than 10 years. So yeah, that's maybe a bit worrying trend there.
Yeah, if I can just reply to that quickly, that's absolutely correct. We are seeing like a halting trend in the build out of onshore wind and also in offshore wind, of course, for several reasons. One is the support for nuclear is kind of skewing the market, as you talk about, Lina, but it's also due to permit reasons. So when the demand eventually comes for the transition, for the industry transition, we might not have enough permits to invest on in either solar or wind. And that is a problem, of course, for the future. Because it's also in several forecasts, for example, Energiforsk NEP studies, where 4 institutes used different models with the same results, that it is onshore wind power that will be the quickest to build until and eventually nuclear build-up is coming, and also to meet the demand before 2035. It will be onshore wind power, but then we don't see corresponding permits that can meet that demand, and that will be a problem. Absolutely.
Speaking about different power generator technologies, how can we gain a better understanding of the interactions between different types of production rather than viewing them as separate solutions? Hamid, would you like to start?
I think we should look for as like a matrix of energy. I think it would not be when we are thinking about the resilience and robustness. I think that the matrix of energy helps a lot in that perspective. I'm not very familiar with other type of energy, but most of my studies was in wind energy and hydrogen, but I think there would be some type of complementary of these like different source of energies. Especially from my perspective, in wind farm, there are many instances that the grid have some type of impact on the production. We have a good wind, we have a good condition, we have a good turbine, but we cannot produce energy because of the grid constraints. And then this would be handled by a matrix of energy. For example, these hybrid farms, as Lina mentioned, for example, the battery storage, the solar, they can handle this type of, because it's not all about the power production, it's all about the grid, it's also about the grid. So, and then this type of hybrid form of energy can help a lot to have a more smooth and more advanced, because usually in a traditional way, we think about only how to produce power, and okay, now we have a power and how to distribute it. But in a more intelligent way, we can look at it as a whole chain. So before designing any type of energy production unit, you should look at it in an overall and bigger picture. That how it, so then it will affect any type of distribution, any type of production, and any type of different sources, I guess.
Lina, Reichenberg, you have been working with different types of production, as you mentioned in your presentation. Do you see how we can gain a better understanding of the interactions between different kinds of systems?
Right. Yeah, I think, I mean, within the research community, so to speak, we've been, there is kind of a consensus since 10 years or so that yes, I mean, there is kind of there is a complementary nature between wind, solar, and anything flexible. In our case, you know, hydropower. So from that perspective, Sweden is unusually well placed to have to integrate a lot of wind and solar, and pretty cheaply. And I think, I mean, that knowledge is already out there. And I only second Hamidreza on the point about the grid, because that's really the problem now. But of course, there's also complementarity between wind and solar on the grid, because wind blows mostly in winter and solar is mostly in summer. So there's maybe room on the grid for more solar, since we already have a lot of wind, and I know it's hard to get grid connection for wind, but maybe there's like an open gap there for solar.
Yeah, and we are entering a discussion about flexibility, which It's my favorite subject. And I was actually wondering, what can research and industry learn from each other regarding flexibility and robustness and the planning of renewable production going ahead? Lina Kinning, what do you think industry can learn from research?
If you mean the wind industry, or because that's the industry I know, well, I think what one can learn is to kind of implement the results quicker through to pointing out what is hindering it. For example, what legislation is hindering to implement better research. And as Hamid pointed out, kind of to broaden the scope a bit, it might be suboptimal to kind of fix a problem behind the meter. You might need to widen it a bit to see the system as a whole, and to have a system approach rather than a kind of production approach only. However, it's because of how the market looks and how the legislation looks. So I think we need to kind of broaden the system scope also to include market and to include legislation.
And
may I add something from my perspective? When I start this project, I think this project, I'm very thankful about Swedish Energy Agency to provide this funding to work, because this was lots of lessons learned for me, especially from when I look at from my perspective from industry to research about the grid, and also about the data, because when I try to design some type of mathematical modeling or optimization, whatever, I'm only looking from myself. But when I know what is the limitation from the industry perspective, for example, in offshore, okay, how long does it take for the permission? 10 to 15 years. I design my wind farm based on the existing state-of-the-art turbine now. But what happened in 10 years? Whole of my design are wrong in 10 years. And I did all design, all optimization about the wind farm layout, about everything with respect to the design of the wind farm based on the state-of-the-art turbine and control strategy that we have now. But when I look at the competition between the wind energy industries, that every day the size of the turbine is getting larger and larger, and now we have a 300 rotor diameter turbine. So I'm sure that in the next 10 years we reach to 500 meter. Then whole of my design, whole of every chain is wrong, and I need to redo design. So I think if I know this limitation, then the research can go in a different direction, and then so we can make ourselves warm up for future changes, let's say. This is, and also about the curtailment, about the grid constraint, about the different parameters that can heavily affect the research. I think it would be good if we can have, and also about the access to the real data. For example, the question, how many sheep per days are needed for the maintenance of the offshore wind? Some companies, they don't give up information. But if there is some type of a national pool that we can have some type of reliable data, then we can design and we can optimize our energy system based on the realistic data. For example, even accessing to this SCADA data requires lots of effort because it's secret. So no companies would like to give this information. So, but if I have this information, then from industry to research, then we open our eyes into the real condition rather than theoretical.
Lina Reichenberg, how do you see research and industry can work to learn from each other going forward?
Yeah, like one of the things that I'm really interested is what Lina talked about before, about this idea of 24/7 electricity production. So basically, one investor in one spot investing in, say, both solar and batteries, because that, I mean, if the appetite for that is really big, then that kind of changes the game plan, I think, also for us as researchers, because a lot of the research in my field assumes that we're going to build a lot of transmission and we can trade variations over large spatial area, so between countries. So wind varies, but typically when it's windy in northern Sweden, it's not necessarily windy in Germany. So we can trade variations, but the whole idea of 24/7 electricity production from one site changes that plan, and I think that's an important tension to explore.
Thank you.
So I'd like to talk more.
Yeah. We will make sure you can get in touch with each other. Our time is up, unfortunately, but I'm very happy that you were here in this discussion today. And of course, we will keep talking.